In the distant past, the idea of a combat walking robot seemed like something out of comic books and movies like Avatar or Robocop. But the South Korean company Hankook Tire Technology has proven that the future has already arrived. Their machine, called Method 2, is the world's first piloted exoskeleton of gigantic proportions, built in reality and capable of moving, walking, lifting, and holding heavy objects. The structure stands about 14 feet tall and weighs nearly 1.5 tons. The pilot is seated inside a transparent cabin that resembles the robot's head and controls the limbs using a console or a motion synchronization system. Method 2 mimics human actions, copying gestures in real time. Each finger of this machine is operated by servo motors, and powerful hydraulic cylinders are installed in the shoulders, allowing it to lift objects weighing up to several hundred pounds. The exoskeleton was originally designed for industrial and emergency use in situations involving radiation, chemical threats, or building collapses. But defense agencies quickly recognized its potential, protection, power, and an intimidating appearance, the perfect combination for military control operations. Even without weapons, a single giant like this is capable of carrying radio transmitters, powerful screens, or surveillance systems in hard-to-reach areas. Method 2 is still far from mass production, but it has undergone real tests. It walked on the floor, moved on a platform, and held metal beams. The company plans to integrate balancing systems and autonomous positioning so that the robot can maintain stability even when moving over uneven surfaces. But the main point in this story is how quickly an idea from science fiction is becoming reality. After all, if a single private company was able to build a walking titan, what might be hidden in the laboratories of defense agencies? And now imagine if such a mechanism became not just a muscular exoskeleton, but a fully fledged combat tank without a driver. The Ripsaw robot tank. At first glance, the Ripsaw looks like a futuristic racing tank, and that's not far from the truth. It's a platform one of the fastest and most maneuverable unmanned tracked vehicles. It was developed by the Howe brothers, engineer enthusiasts, and later adopted by the US Army for real combat needs. The most shocking thing is its speed. The Ripsaw is capable of accelerating over rough terrain up to 40 miles per hour, making it several times faster than most tanks and armored vehicles. At the same time, it is fully remotely controlled, and in the latest versions, artificial intelligence has been integrated, allowing it to navigate terrain independently. The combat module includes a cannon, a machine gun, and the option to install missiles. Control can be carried out from a safe distance. Such a machine can serve as a scout, a base guard, or be the first to attack when it is too dangerous to send people. The Ripsaw has undergone testing in both desert and forest conditions. It cannot be stopped by simply blowing up a wheel or a track. It features a redundant drive system and an armored capsule for its internal equipment. The US military is seriously considering it as the basis for the next generation of light armored vehicles. But the most frightening feature is its silent movement. Electric drives and hybrid propulsion allow the Ripsaw to approach its target unnoticed. It is not only faster than most vehicles on the battlefield, but also quieter. If an unmanned vehicle can race across the battlefield with a cannon, then why not create a true autonomous fighter with tank armament? Black Knight. Black Knight is a project that looks like an ordinary tank, except for one unnecessary element, namely the person inside. Created by BAE Systems, this combat robot weighs about 27,000 pounds and is equipped with a 30mm automatic cannon, a coaxial machine gun, and armor sufficient to protect against light firearms and shrapnel. But the main thing isn't the weaponry, it's the brains. This tank can move autonomously, plot its own route, search for cover, and even choose positions for attack. Its control systems are connected to panoramic cameras, lidars, distance sensors, and machine vision systems. The platform was tested in simulated combat conditions. The operators only set the objectives, while the Black Knight chose the route, found cover, and even analyzed potential threats on its own. The vehicle can be part of a coordinated attack, exchange data with other robots, drones, and command centers. Although it is not yet in service, the US Army has officially stated that such platforms are the future of their armored forces. And if an autonomous scout is already a reality, then a fully fledged robot tank on the battlefield is no longer science fiction, but the next step. Now let's move to India, a country that in the shadow of superpowers has created its own army of robots. Muntra is an Indian unmanned vehicle. Muntra is India's first family of unmanned military platforms, developed by the Defense Research and Development Organization. The vehicles are based on the well-known BMP-2, but have been modified so that they can now carry out missions without a crew. There are three versions of Muntra. The S version is a scout, equipped with night vision cameras, radars, and lidars. It can move across the battlefield, transmit real-time data, detect hidden targets, and even suggest routes to infantry. The M version is designed for mine clearance and carries equipment for detecting explosives. And the N version is capable of operating in chemically contaminated environments, gathering data and maintaining communication. Each vehicle can be remotely controlled from a distance of up to 9 miles and can also operate autonomously using navigation algorithms. Tests have shown that Muntra successfully moves across rough terrain, avoids obstacles, and synchronizes with other vehicles. Thanks to its cost-effectiveness and versatility, Muntra could become the foundation for entire unmanned units. This proves that the race to robotize the military is not just between the US, Russia, and China. And now imagine if not only reconnaissance, but the entire logistics on the battlefield became autonomous. The driverless truck TerraMax. The TerraMax system, developed by Oshkosh Defense, is a true workhorse of the army of the future. It allows heavy military trucks to move across the battlefield without a driver. The idea is to replace people on the most dangerous routes where there are mines, ambushes, or snipers. The system is installed on existing platforms, MTVR, MRAP, and PLS trucks, equipped with LiDAR, radars, GPS, cameras, and an onboard computer. The vehicles can move autonomously along designated routes or follow a lead vehicle. All of this happens without a driver inside. Tests have shown that a single operator vehicle can coordinate up to 5 or 6 TerraMax vehicles at the same time. The convoy moves precisely, avoids obstacles, and responds to sudden threats. If necessary, the vehicles can stop, change their route, or turn around after receiving a new command via a secure communication channel. The system has been actively tested at training grounds and in real missions, and is already being used to a limited extent. Obviously, no one risks their life transporting ammunition or fuel over dangerous roads. And that's just logistics. Next, we dive into a world where weapons not only drive themselves, but also fire based on decisions made by a neural network. SGR Aeon is a robotic sentry. Perhaps one of the most sinister examples of military robotics has long been stationed on the border between North and South Korea. We are talking about the SGR Aeon system developed by Samsung Techwin and Korea University. This is an autonomous sentry robot equipped with a machine gun, a thermal imager, and a target recognition system. Mounted on a stationary platform, the SGR Aeon can patrol the perimeter around the clock, conduct surveillance, and if necessary, open fire. Yes, this machine is indeed capable of independently making decisions to engage a target, relying on a variety of sensors, thermal images, sound, movement, and imagery. The robot can detect a person at a distance of up to 2 miles and distinguish their behavior. If the target approaches, it issues a voice warning, and then, if configured to do so, can open fire without operator involvement. The SGR Aeon is armed with a die-weak machine gun and a grenade launcher. It also uses a sophisticated friend or foe identification system. However, experts still debate how reliable these systems are in actual combat. The main point is that this is the first mass-produced system where firing can be carried out by the machine without human intervention. And while these machines are currently guarding borders, tomorrow they could become part of the front lines in any war. But what if the front line isn't a line of fire, but rather complex routes among hills and ravines? Racer Heavy is DARPA's all-terrain robot. DARPA is known for its crazy yet incredibly high-tech projects. One of them is the Racer Heavy platform. This is a fully autonomous tracked vehicle designed to operate in conditions where other vehicles simply can't cope. Unlike other robots, Racer doesn't just follow a simple map. It perceives the terrain in real time using LiDAR and advanced sensors, assesses slope, soil density, the presence of obstacles, and recalculates its route on the fly. The unique feature of this machine is its exceptional stability and its ability to recover movement even after collisions or soil shifts. It has been trained on millions of scenarios, and the AI selects a strategy based on a machine learning model rather than a fixed algorithm. Tests have shown that the platform can traverse areas where neither a tank nor an ATV could pass. An ultra-low center of gravity, advanced suspension, and the ability to maneuver sideways make the Racer a true master of difficult terrain. This machine is not armed, but that's only a matter of time. In the future, the platform could be equipped with combat modules or used as a transport for other drones. For now, it demonstrates just how much smarter and more effective autonomous technology can be compared to humans in combat situations. But what comes next is not just autonomy, but technology that disappears right before your eyes. DARPA Invisibility and the Stealth Truck. The American DARPA is working on projects that make vehicles invisible not only to radar but also to the naked eye. One such project is an experimental armored vehicle covered with a material that has a variable reflection coefficient. It changes its color, thermal signature, and even the shape of the reflected image depending on the environment. This is not a movie. Prototypes are already being tested that, when viewed through a thermal imager, blend completely into the background. This is achieved through active camouflage coating covered with thousands of miniature screens or plasma modules. One of the prototypes being tested is a truck based on the JLTV platform covered with an adaptive shell. Visually, it appears as an invisible spot against the background, making it difficult to distinguish even when viewed through binoculars. The developers claim that the goal is to make the equipment completely invisible on the battlefield so that even flying drones cannot detect it. It's not complete invisibility like in the movies, but even now such vehicles throw off missile targeting systems, evade thermal sensors, and confuse reconnaissance drones. And now imagine a vehicle that not only avoids the enemy, but doesn't need a driver at all. Robot Combat Vehicle, a lightweight killer. The RCVL is a light robotic combat platform developed by the US Army in collaboration with Kinetic U. Its mission is to serve as the forward eyes and guns on the battlefield. It's a small but powerful armored vehicle capable of moving autonomously and being remotely controlled from up to 20 miles away. Its armament includes a 30mm automatic cannon, an active protection system, thermal imagers, and reconnaissance drones. It weighs about 7 tons, can be transported by helicopter, and deployed at any point in a conflict. The RCVL has already participated in several field tests, including maneuvers over rough terrain, night attacks, and urban assaults. The vehicle has demonstrated that it can operate in conjunction with other platforms, acting as either a strike point or an observation post. Its main feature is its intelligence. It analyzes the terrain, selects positions, fires with perfect accuracy, and can evade attacks faster than a human could give the command. This is not just a replacement for a soldier, it is the soldier of the future. But the pinnacle of all these developments will be a machine controlled not by a soldier or a computer, but by nature itself. Quantum Stealth, the invisibility cloak. In reality, the company has developed a material called quantum stealth, which can completely conceal a person or object from visible light. And now it has begun to be tested on military equipment as well. This material does not require power, does not emit light, and does not heat up. It works by refracting light. Light waves bend around the object, making it invisible. In tests, the developers demonstrated how a person disappears against the background. And the same thing happens with mock-ups of equipment. For now, quantum stealth is mainly used for individual camouflage, but experiments are underway to cover entire vehicles. Imagine an armored vehicle that disappears in smoke, or a drone that is invisible both in the visible and infrared spectrum. The developers are collaborating with several armies around the world, and although the project is classified, leaks suggest that the first prototypes are already undergoing field tests. A train for tanks. While the world is focused on drones and robots, China is taking a different path. It is turning railways into combat front lines. A project that was classified for a long time is now known by the unofficial name Next Generation Military Armored Train. Its goal is to transport heavy equipment, missile systems, and unmanned complexes along internal routes at maximum speed and with minimal vulnerability. The train consists of low-floor platforms, each of which can carry either one tank or 2 armored vehicles. In addition, several cars serve as command centers, drone launch stations, and electronic warfare modules. All of this is protected by armored shields, active missile defense, and short-range air defense systems. The main feature is mobility. Within a few hours, the train can deliver an entire group from one end of the country to the other without the need for airplanes or convoys. A rail autopilot system is used, as well as even laser complexes for destroying obstacles on the tracks. And this is not a story from World War II. This is modern technology, currently undergoing testing and already actively used in the logistics of the People's Liberation Army. The only question is how soon such combat trains will be operating in active combat zones. But now imagine a tank approaching the shore that can swim. The US Navy Sea Tank. At the intersection of military shipbuilding and armored vehicles, a project for a sea tank for the US Navy was born. An amphibious platform that can emerge from the water, land on the shore, and immediately enter combat. One of the most well-known examples is the AVIP Sidewinder. But there are also more recent projects, such as the ACV, Amphibious Combat Vehicle. The ACV is being developed for the United States Marine Corps. It combines armor protection, mobility, and the ability to disembark from a ship. The vehicle can travel dozens of miles over water and then continue moving on land without losing speed. It is capable of carrying up to 13 soldiers and is equipped with a cannon, automatic modules, and surveillance sensors. Tests of the ACV show that the vehicle can withstand heavy coastal surf, does not capsize, and maintains movement even in harsh ocean conditions. In addition, it can operate as part of a floating unit, synchronizing with other vehicles and ships. This is no longer just an armored vehicle with amphibious capabilities, it is part of a new doctrine, the capture of the shore in a single leap. And now these amphibious vehicles are turning into fully fledged strike units, with armor, firepower, and the ability to operate independently from the fleet. But what if these vehicles were delivered not by ships but from the air? NATO Airship. Airborne platforms are making a comeback. NATO and private contractors have begun reviving an old idea, military airships. But now, these are not slow gas bags, but hybrid airships capable of hovering over the battlefield, transporting equipment, and deploying troops with the precision of a drone. One of the projects is the HVA-304 Airlander, developed by the British company Hybrid Air Vehicles. It can carry up to 20 tons of cargo, remaining airborne for more than 3 days. This is an ideal platform for delivering equipment to remote regions, especially where there are no airfields or suitable roads. Military versions are equipped with protection, electronic reconnaissance systems, and can function as communication relays or drone launch bases. A single such platform can hover over a conflict zone and coordinate the actions of an entire battalion. The main features are its silence and altitude. These machines are harder to detect. They do not require runways and can hover over mountains, deserts, and jungles. This is a quiet revolution in logistics, reconnaissance, and tactics. But what about speed? What if a combat transport could immediately hover and race faster than the speed of sound? A supersonic transport. In a world where drones and unmanned vehicles conduct reconnaissance and autonomous tanks engage in battle, cargo delivery still takes hours. This is exactly what the XSON project from Boeing and DARPA is trying to change. A supersonic reusable aircraft capable of delivering payloads to any point on the planet in just a few hours. The XZone is not just a transport, it's a space truck that launches like a rocket, reaches suborbital altitude, and then accelerates to hypersonic speed. On board, drones, satellites, equipment. After completing its mission, it returns to Earth like an airplane, ready for its next flight in just a day. Such a vehicle can be used for urgent deployment of military equipment, evacuation of valuable assets, or the deployment of communication satellites. It is an absolute record holder in terms of speed, reliability, and versatility. It is currently in the testing phase, but its potential applications are already being discussed by NATO and the Pentagon. If the project succeeds, the world will gain military logistics at jet speed. And all of this leads us to a machine that combines everything: mass, power, autonomy, and technological superiority. The main monster of the planet. It doesn't fly, vanish, or dive. It simply crushes. The Armata T-15 is one of the heaviest and most powerful armored personnel carriers ever created in modern history. This Russian vehicle, built on the Armata platform, weighs over 60 tons, is armored all around, and is equipped with an active protection system. Its main task is to deliver infantry under the most challenging conditions, in direct contact with the enemy, under fire, and in devastated urban environments. On board, it features a module with an automatic cannon, a drone suppression system, and a 360-degree surveillance complex. This vehicle is capable of moving through destroyed buildings, breaking through concrete barricades, engaging in combat on the move, and carrying up to 9 soldiers on board. Inside, it's not just armor, it's a digital command center where every soldier receives real-time data. It's often compared to a tank, but it's more like an assault fortress on tracks. And although only a few of these vehicles have been built, the very fact of their existence shows just how far ground combat technology has advanced. Each of these vehicles is not just a piece of equipment, it is a symbol of a new era of warfare, where the soldier is not always human, and the battlefield is a domain ruled by sensors, AI, and power. The world has already changed, and the technology you've just seen is the main proof of that.